Hey guys, Esky here, or Noah King, as is titled on my authorships. It is my formal name. Um, it's good to see you today. This is actually a third retake of my video log regarding my scientific and mathematical theories and inventions book. This book is basically a book that I have written over the past few years regarding some ideas in particle physics, geometry, mathematics, um, logic, um, things like circuitry, even chemical engineering, medical technology, and etc. Um, the last edition of this video log, I think I scrolled through a little bit quicker in some places than others, and I didn't really give adequate descriptions and jumped around a lot. I also tried to translate a lot of what I was talking about into my language that I invented, um, which can be decoded using a meditative process, according to my theories. If you watch my other video logs on how I invented my language, I was able to confirm with other people who've tried the method I used to create my own language, and we were able to understand each other's languages. Now, it was a little bit difficult to just go through and say what's going on in English and then, take breaks and say it in my language. So what I'm going to do is I'm just going to go through this whole thing in English, and then at the end I will quickly provide some comments in my language. Now, that's why I call myself Esky anyways. It's not incredibly pertinent to this, but it helps for educational purposes. So, this is the cover page of my article in PDF format. This Scientific and Mathematical Theories and Inventions by Noah Gerard King, which Gerard is my middle name. Not everyone knows that. But here, this is a hardcover edition, author edition. You can see it says not for resale here, but this is basically the hardcover that you can obtain from Amazon. It's got mostly same stuff that you'll be seeing over here in it. Just there's also a paperback and a Kindle ebook, which the Kindle ebook doesn't have perfect formatting, and I'm not a Kindle formatter, so I just. But the point is that you can obtain copies of this hardcover or paperback, or you can seek me out by email, which is listed on my YouTube channel's About section. If you want to get free downloads of my PDFs or my articles, I can provide you with those. I believe that these should be distributed, so if you want to print them out for free, I will. Otherwise, Amazon publishes for me and prints some very nice hardcovers and paperbacks at a quite affordable price. I'm just playing some of my music in the background, Nitrous O. When I'm done recording, I'll make sure it's not too loud. I post videos of this stuff on my channel all the time, so anyways, down to brass tacks. This is going to be a video that describes the basic fundamental concepts discussed in the book. As well, I'm going to take time on every page so that if you scroll through this, you can actually read the whole document. Just kind of watching this video, but so I'll give a generalized overview. I'll give a generalized overview of what's going on in this as we continue through the book. You'll get a simple description of what's going on. So here we go. I'm gonna simply move my window over a little bit, and so it starts with this page is on quantum energetic theory. As the title is basically just my descriptions of how I believe some of the mechanism of particles, elementary particles, will behave under given kinetic rules, and establishes some of the dynamic of my keywords and my perspective in terms of which parts I consider a core part of the analysis of kinetic activity and what etc. that means. And then section 2 here, this is all sectioned off, so you'll just keep going up from number 1 throughout this whole thing with little articles. Sometimes they aren't directly related to each other, but this one, this section really just talks about how I view the nature of physical laws and what geometrically and really matter is, and in which ways I describe it in terms of forces to help break things down on a simpler level. This is actually not something that even necessarily pertains much more than to logical theoretical physics, because it is to describe mostly on a more general level what forces are. You know, there's other types of forces than fields on the particle level in my ideology, because you may assume that there is some kind of definition or boundary of matter plus a field that it emits, and that those are two different things. So it goes over that. It just kind of breaks down those concepts, and then it relates why this perspective is useful in formulating equations and stuff, and really diagnosing what things in physics are in the future. It's pretty good. The intro is mostly just a little background on how I view forces. Some of it is different from modern theory, and that's the same throughout this whole book, is that you'll get parts that don't necessarily pertain to modern theory. But I'll stop scrolling up and I'll just continue here. As we go down, you'll see that there's spots throughout this section number 2. I talk about how the mechanics of and potential underlying mechanisms that are rooted in atoms in existence, that maybe fine details we don't focus on when we talk about orientations, charges, and positioning, etc. of particles, which opens up for a lot of other technological definitions and potential applications later. And these aren't always incredibly clear, but this general section here will go through what general purposes, different classifications of particles based on the ratio of the activity of their forces and the nature of them is, and then and some theories about modernly classified series of particles and what they do. So then this next part here, then it gets, this section 2 will get into a little bit about how I even believe the structure of photons and electrons to be, and it's pretty interesting. Basically, I kind of view a photon very much as an energized electron that has lost a degree of stability, in that upon, you consider it the speed of light, but my theory defines it slightly differently, that the speed of light isn't necessarily an energy limit for, or a velocity limit for a photon or an object, but it is related to a limit where photoelectricity or photons will break apart and dissociate, or can be transferred in different levels of energy, and this break point is kind of the reason why photoelectricity interacts with atomic materials the way it does, and that's one of the reasons why I relate them more closely. And now that's not, you might almost go through some basic physics courses and think a photon is an electron, but usually they are quick to say, well, it's not quite. In fact, we're not sure how they're related, but this is my stab at a theory. Then it does some simple talks about particle physics and how different particle fields. Now I know there's recently we've kind of dismissed parts of the Standard Model, and the Higgs boson is one thing. We really don't know what the effect of it is. And I'm not going to, I write this book so that people who have no idea what a Higgs boson is can still understand parts of this just by, Googling parts here and there, or just imagining with a basic understanding of what particles are and what they do in physics and the modern theory that things are made up of particles, in general, that you can get an idea of what I'm talking about. So what I say in this part of the section is just a little bit about how applications of particles in a very advanced context can potentially be used to create irregular behaviors in atomic materials that would be highly commercial or industrial, technologically useful. Number 3, I just talk a little bit. I talk a little bit about things with gravity, and I use the term relativity in this kind of loosely because I don't believe in general relativity, Einstein's theory of general relativity, and I not exactly perfectly discuss it throughout this whole book, but I believe that the net effect of those relativistic equations results in a displacement of reality where it becomes subjective from any point, and I believe not just for scientific but philosophical reasons that's not true. But this section is called objective observation because this basically provides a method for taking into account an effect like relativistic gravity or gravity itself, or other scenarios, and finding better ways to objectively evaluate or analyze physical scenarios with that. And there's a brief section that talks about observation devices for observing particles or recording them. Taking measurements of them in suspended states is really important to me because I also do not necessarily believe that in order to observe something means to change it. I don't believe that's a general heuristic, but it is, in general, the phenomenon of observation is associated with a change in material effects, but I do not believe it is necessary. And there may be a very simple and universal route to obtaining observations in this way, but I just do a quick brief section on that there, and some things about potential forms of batteries, and some observations about and the behavior of electron carriers, and a little bit about electrochemistry, and this later relates to other useful applications of crude electrochemistry later. But I'll just skip through that because that's basically what that's about. The explanation why I believe these theories would be effective, despite the fact that they have not been tested very well at all and these experiments have not been done, is described in terms of quantum mechanics and whatnot down through there. Proposal on the oscillation movement of shapes and their general mapping. That's number 4. That's just interesting observations when you put shapes on a graph and you perform simple kinetic operations with them. What wave constructs and material tendencies of the coordination of points are, and that I just wrote about that. See, I just scattered in some geometry and math and random parts of this sometimes. Number 5 talks about power, kinetic, and conservational technology. This is just a section where I talk about potential ideas for vehicles that run on water, or better ways to reduce emissions using electrolysis and whatnot. Number 6, I talk about potential ways to run semiconductors and go on to talk about some circuit elements I invented. If you're watching this and you take pause breaks every once in a while and you read this, I bet you'll have a lot of fun. So I'm just going to scroll through these graphics. It's funny, a lot of the stuff in the physics sections here is not proven at all. But it is very interesting, and my mathematics is mostly proven and or has a lot of basis as a theory. What we'll get to that later. 7, this section talks about some hints I believe I've obtained, or some effects that I believe would be relevant to the application of some of my theories in quantum informatics, and how information is stored in atoms and how that can affect measurements in laboratory experiments. This is one really easy way to test the validity of a lot of my theories, and I have a lot of mechanical reasons with what we do know about the behavior of particles, that in theory they should work in this scenario. Number 8, this is where I really talk about the meat and matter of the importance of my particle physics theories, because I believe atomic materials, because of the way they geometrically resonate, have space gaps and energy gaps and potentially other field effects that evolve for other more advanced geometrical reasons, that infer that you can harness the energy of a lot of elementary particles we usually only even witness in a large hadron collider or some other particle accelerator, or during radioactive decay events or whatever. Well, this is a big section here that talks about how you can mix together different forms of energy that don't normally or not predictably interact. They may produce minute changes, and if you amplify these in the right order or with enough energy, you may be able to actually harness relatively useful forms of energy that behave much differently than normal in laboratory circumstances. So then we have number 9. This is just talking about wave constructs and their and some computer stuff and geometry, and how computers relate to compute these kinds of things, what that means for computers, and data theories on data, and probability, ways to compress pieces of information, and it goes over some number sequences as well. So there's this concept up here I actually underlined. It's the perfect probabilistic hemicircle of computer probability, which may be very useful when you design data structures that have to do with liminal spaces and obtaining a relevant computation. It may be a certain rating scale for complicated equations and factoring out relevant lengths of calculation for any given component to get an accurate overall result. This is for advanced reasons that are talked about through the whole section. You can piece it together. Then I got some equations that deal with the property of shapes, where on the x-axis you get the number of points on the graph that comprise the shape, and then whether it's fit in a circle or whether the segments between the points are 1. This will describe how those shapes are constructed and what properties they have by default. Then it talks about some fractal sets that I discovered. And this section is about genetics. This one is I also talk about how you can synthesize at large lots of different biochemicals using electrochemistry. This is going to be really interesting because while the yield will be incredibly low, initial concentrations, you could do thousands of these experiments during these reactions, and you get large amounts of very expensive materials that are very hard and expensive to synthesize on their own. And as long as you isolate them from the crude mixture after, this may be a very cheap way of doing advanced syntheses. 11, this is just to do with the geometry of things. I'll give a basic description for number 11 because I was just thinking about this today. What can demonstrate my section on 11 is if you know those little hologram chambers which have convex mirrors stacked against each other, concave mirrors stacked against each other rather, and it has a hole in the top, and you put a pig in it and it makes a hologram of the pig, the plastic pig, coming out of the top. Well, one thing you can do with this data in 11, you can construct a similar 2 spheroidal mirrors with the mirrors on the inside of the sphere, and you suspend glass magnifying lenses, magnifying spheres, in both chambers, and you allow an entry for an object into one, and you allow projection to come out the other, you'll get some very interesting geometric effects that kind of relate to complex numbers and stuff, and a lot of translations in space. And this would be a very interesting invention. I can't wait to try to make one of these, but obviously that's not easy. But that's what that talks about. Then number 12, I talk about some music instruments I made. Invented, want to make. Number 13 is about a theoretical synthesis for neuromelanin and adrenochrome. I tested it out. I haven't gotten the results analyzed by a lab, but I have reasons to believe, because of the carbon dioxide evolved, that this silver chloride decarboxylates indole carboxylamides just like copper chloride, and it's less toxic. And that if you have neuromelanin from this reaction with eumelanin and silver chloride, you may be able to just simply add hydrogen peroxide to obtain adrenochrome. Those are some obscure chemicals that, some people say they don't do anything good for you. Other people say they're good. I know neuromelanin is suspected of having some important medical value. I'm not advising anyone take any of this, but this is my stab at finding an economic way of making it. And then I talk about how you can use melanin in general for mining soil. I believe it yields a lot of manganese, but again, this is something I haven't analyzed. I just know you get a lot of metal from soil doing this. So I guess it depends on the soil. This could be used for precious metal, and it's very environmentally friendly. 14, it's just talking about a potential medication administration invention I made. 15, I talk about potential seemingly almost alchemical or really complicated mixtures of metals, and how you can potentially use advanced combinations of especially diamagnetic and ferromagnetic with paramagnetic materials in alloy, and you might be able to create better superconductors. I think the diamagnetism is very important to forming superconductors at room temperature, just because while it's a weak resistance to magnetism, it may evolve into superconductors with this diamagnet material. 16 is just about a number of interest that shares properties with infinity, and it's equal to 134,279,985. I'm going to go over it basically. Is that if you sum or subtract the inverses of powers of numbers, squared, cubed, etc., from the inverse of the number itself, you end up with the inverse of n minus 1 or plus 1. And this number has an infinite series related to a series of powers of 2 and 3 and multiples and sums that if you modify that equation that synthesizes the number, you will get two numbers within one of it as an inverse when you calculate this infinite series. So it's pretty interesting. And then this goes into my collective mathematical work section right after this. There's no more of those physical theories, but this talks about new formulas for the trigonometry of isosceles triangles. I'm going to ask anyone who's going through this to stop and just read the abstract of this and everything, but basically this is a better way to do trigonometry. And it's actually crazy this hasn't gotten places yet, because I've had this paper for more than a year. It's a better way to compute angles in physics because it makes you run around less to do calculations. When you program this into a calculator, it'll take either 1, 2, or 3 numbers based on whether you got isosceles, right triangle, or any type of triangle with 3 sides. And you input those values, and it uses a unified formula to solve them all, or an even simpler one if you got specific cases. And that's way better than I saw the old sine and arcsine methods right away. But beyond that, it comes with the other cyclic function. It converges faster, and it goes to positive and negative 180 degrees. So you get a full 4 quadrants of coordinate data preserved on the Cartesian plane or radial graph when you normally wouldn't. So that's that. And it goes through all the formulas here. It's better for doing physics. It's better for doing absolutely everything we do with trigonometry are these formulas: physics, geometry, applied math, complex equations, all that. It's all done. This is way better, and there's a better way to synthesize pi. And there's even a way this equation, unlike the others, will condense any graph into a single number. And this is how, right here. This graph XYZ equation. Although it assumes that x to y and x to z start at either 0 or pi radians, obversely to each other. Now, the rest of it, there's just a discussion and then an ultimatum on its uses and application. And I even had some references because I submitted this one. This one is really interesting too. This is my postulate of time as an imaginary dimension, physical space is real dimensions, so that time and space is a single complex number that exists at every point, basically. And then the behavior of negative versus positive numbers. This is basically where I talk about if reality is an equation, numbers are immaterial, and here's how. It also says time is not a line or a dimension, it's just the way things go. And the last thing this article says is that negative numbers multiplying to form a positive number is too many assumptions about negative numbers. I look at graphs like a left and right-handed side thing, and you can recreate every graph and more easily and more understandably if you assume that this is not true, but rather basically the major modification is listed, and they're listed down here, but these a, b, and c right here, and that negative 1 over negative x will result in negative 1 over x. Positive 1 over positive x will result in the value 1 over x. But if the signs are different, they will result in just 1 times the number, positive or negative. So this is going to assume that you no longer have a positive and negative side that deals with addition and subtraction. You may as well just say they're left and right. So yeah, it works for everything. It doesn't even touch applied mathematics 90% of the time, if you just start assuming this right away. But in certain scenarios, you do want to add negative 1s over something or 1 times something or whatever in order to flip the graph the right way. It also changes the property of the imaginary unit I a little bit, where things will be indeterministically positive or negative unless you specify an indeterminately positive or negative thing under I, and then it becomes whatever the sign of the determining component is. So you can have left, right, positive, and negative as precursors to a number. Then you got all that. That's there's a lot of evidence there. Then this one talks about how infinity rounds numbers, and it's interesting, and I hope you read it as well. It's another theory of mine about how you can use infinity to round numbers, similar to how 0 times 0 or factorial 0 is equal to 1, according to my theories and others. And this is about a bunch of irrational numbers, some of which had spoken to me in dreams, like mu 1.19758. In 2017, it said, I exponentiate to infinity perfectly, and it said I am 1.19758. And if you go down here past some geometric properties, you actually find out this number is like past the 1 in a million chance that at those decimals it actually does correspond exponential relationships in simple algebra. There's not many of these numbers in existence, but that's basically what it is. It goes over a bunch of others. I believe these have maybe applications in applied physics, particle physics, geometry, engineering, optimizing things. I haven't explored it all yet. It's hard, but there's a lot there. And then it just goes over some counting sequences that I discovered. I think my screen might have blurred that, so I'll let you scroll through these. This is another sequence. I actually coded a pretty advanced AI to enumerate, and this is basically the result of what numbers are possible between integers 0 through x as the index of the sequence, where you combine them together in addition, subtraction, multiplication, division, powers, or roots. Any possibility of any two numbers that are integers between 0 and x, and the number of unique numbers you get. So if you get a single number twice, you only count it once. And that's the sequences. These sequences are. And they're very interesting. And then there's another one I wrote on the number of the maximum number of possible axioms you can achieve when you consider a number of geometrical points, 0 through x, in any number of dimensions. So that's what this sequence is, and it's quite easily listed here, up to, well, 6, 0 through 6. And then this is my paper on biodes and transratiometers, more in depth, and that's just some circuit components I invented that I believe simplify computers. So you should read through that too. This may be very important to computational science, and you may be able to build resonating circuits that are effectively analog computers out of these, using like a very large number, like 134 million of them. So I'll just leave this out with a short note for those who have learned my language that I invented, or made their own and come to understand how I made mine, to see if you understand it as I speak mine. Just to summarize, I'll make a simple statement about this book in my language. It's a nice day, and I'm glad to be making this hopefully final edition of the introductory video log to this very important version of my Scientific and Mathematical Theories and Inventions book. I hope you guys have a great day, and I'll see you again soon.